My name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will understand what is autoencoder and how it works. Okay, so let's get started. The first thing, what exactly the autoencoder? So an autoencoder is a type of artificial neural network which used to learn efficient encoding or features from the unlabeled data points, right? So unlabeled data points means it is unsupervised technique, right? So it will not require any labels. So we can write, let's say it will be unsupervised learning, right? Let's say it is unsupervised. Okay, so what does it basically do is it will compress our original data points into a lower dimensional and then reconstruct it back into the original one, right? It will not exactly original one, but it will be a very similar to original point, right? So if you see here, so basically autoencoder has two major component, encoder and decoder, right? So task of encoder is to convert our input into a lower dimension, right? Let's say this is basically any let's say 1024 dimension, right? And now we will convert this using neural networks technique into, let's say, 100 dimension, right? And after using this 100 dimension, the decoder will try to regenerate the original data point, right, which is 1024, right? So you can think it as a zip file. You have one large file, you are compressing it into the zip file, and then you are decompressing it, right, and get original point. But it will be very similar to original but not exactly replica, right? So this is about how encoder works, right? And this bottleneck or compressed data point is called as a bottleneck because the encoder will force to learn the very rich feature information from the original input, right? Because we need to regenerate it as well from this bottleneck features, right? So you can use any kind of data set. It could be image or it could be any tabular data format as well while you are training autoencoder. So how the autoencoder will train, right? What will be the input and what will be the loss? So basically we don't have any label. So we are just input and extracting the output as an input, right? So input and output, when the input and output is the same, the loss is zero. So in simple, we are just comparing input and output, right? Let me write it here. Just compare input and output, right? So you can use any MAC or anything between input and output, and that will be your loss, right? So let's understand one practical example from the diagram. So let's say I want to create an autoencoder which can use or train on the MNIST data point, right? So here I have one image, right? So let's say this image is basically 28 cross 28 cross 1 shape, right? And to encode it into a lower dimension, or you can say latent space or bottleneck features, let's say my bottleneck feature is 64. Okay, so if you see this 28 cross 28 is basically nothing but 786 dimension, right? So we will use encoder to compress this 786 into 64. So here the encoder will be convolutional neural network, right? Because we are dealing with the image, right? So it will be convolutional operations. And then we are converting this image into 64 dimension vector. Here we will also use convolutional operation, which is basically a transpose convolution, which will upscale the image because we need from 64 dimension to again 28 cross 28 cross 1, right? So this will be our encoder setting and decoder setting, right? And this bottleneck feature will contain very rich information. For in this case, let's say it will contain the information like how many curves are there or what are the shape information required to understand this 6, right, into a smaller dimension. So this is how autoencoder works, right? So let's understand what are the use cases of autoencoder. So first use cases can be dimensionality reduction, right? Dimensionality reduction, right? Because if you see here, we are converting 786 dimension into 64, right? If you use this bottleneck representation or bottleneck features, it can be your compressed version of your data point, right? So you can see it is dimensionality reduction, right? So you can say like why we require this as a dimensionality reduction. We already have that PCA and TSNE, right? So if you see PCA is basically nothing but linear projection, right? But in autoencoder, we are using a neural network. So it will understand non-linear patterns as well from the data point, right? So that's why it will perform better than the PCA, right? So you can say it is better than PCA, right? Second thing. So second, it can be used as an features, right? Or you can say feature extractor, right? As we learn, this bottleneck feature is basically nothing but a feature rich representation of this 786 dimension. So you can use it as a feature as well, right? Third will be, let me rewrite, right? Third will be anomaly detection, right? Okay, so how it can be used for the anomaly detection or detecting the outliers, right? So if you see what we are doing here, we will take our input and convert it into lower dimension and then reconstruct it, right? So if the data point is very similar to our training distribution, right? So it can regenerate it very well, and at that point the input will be very similar to our output, right? Because let's say we have used a MNIST data point, right? This handwritten data point, and it is trained very well and it is reconstructing very well, right? So if some outlier came and we pass through this autoencoder and it will generate a reconstructed new output, right? Then the difference between input and output will be very large, right? It won't be a similar, right? How we can say, let's say you are just calculating the mean square error between two images, then if there is an outlier point or anomaly point, it would be very high. You can set any threshold there by seeing our training and testing point, right, to predict the outlier or detect the anomaly, right? Okay, so this will be anomaly detection, right? Fourth will be denoising, right? So you can train autoencoder in which input will be noisy image, right? Let's say noisy image, and the output will be a clear image, or let's say a less noise image, right? Because it is basically doing input as an image and output is also image, right? So you can remove the noise from the image as well. Okay, so if you say fifth point would be generate new image. Generate new image. So there is an enhanced version of a autoencoder which is called as an variational autoencoder, right? So we will see in upcoming video how variational autoencoder works, and we will implement it as well. So basically variational autoencoder will generate a new images which are very similar to our training point, right? So it can generate new image which is not in the training set but very similar to training point. So these are the use cases of autoencoder and the technique, how it works and how we can use it, right, in the real world. In next video, we will implement autoencoder using TensorFlow, right? So if you like my video, please press like button and subscribe my channel and share it with your friends so they also can learn, right? We will meet in the next video. Thank you.